right, here we go. We are doing 2.8 today. And we are talking about similar figures. This is figures with the exact same shape, but different sizes. Same shape, different sizes. So that means that the things are, the sides that are in the same place are similar to each other. They're proportional to each other. All right, so let's say I have two triangles. This is triangle ABC, and this is triangle DEF. These two figures are similar figures. Okay, they are just different sizes, which means different parts of them go together. Because they are the same shape, all angles are equal. So we're going to start with those. So if you were to talk about these two similar figures, angle, and this is the shape for an angle. Sometimes I put a little curl through it. Angle A is equal to the same angle on this triangle, which is angle D. Angle B is equal to which one over there? E, very good. And angle C is equal to angle what? F, good job. All right, so that's the first thing. When they're congruent, you just say they're equal. All right, when the angles are equal. We got to talk about the sides, though. The sides are proportional. Okay, so we're going to say, we'll start with this one, go from A to B. Is proportional, so we're going to put it over top. I'm going to move it up just a little. I don't want to go too far because I want to be able to see it. But let's try that. AB. I got to go up just a little so you can still see our triangles. There we go. AB. What side over there is proportional to AB? DE. So right underneath AB, I'm going to put DE. And then we're going to put a little squiggle in between, because it should be equal to it. Now we're going to go to the next side. We're going to say BC is proportional to over here. The same side is EF. We're going to put a little squiggle. On the last side we have, let's go CA. If I'm going right around my triangle, is proportional to what? FD. Very good. Oh, well, there's only 3 sides, right? Okay, if there were 4 sides, you'd have one more. Okay, so any questions how we're like comparing these two? Yes. That says this angle right here. Oh, okay. No, so because those two angles are equal, they're the exact same shape, the angles have to be equal. Okay? This is proportional, though. We're going to talk about this in a second. It just means that if I were to divide these two, that these two divided would get the same number. Okay? all that means. So, let me show you what I'm talking about. Here is example number 1. Let's say I have those two triangles again. And I tell you, this side is 32, this side is 36, and I tell you, this side is y, and this side is 45. Okay? The way we just set it up, we take and we make a fraction. This side, which is 32, over the same side over here, y, equals the bottom over the bottom over here. Okay, now, we have two fractions. They're two proportions. To solve proportions, we can do what we call cross multiply. Sometimes they call it the butterfly, right? Where we can actually take this angle equals multiplying these two together. So we're going to say 36 times y equals 45 times 32. Well, just because I still have to multiply them. All right, so 45 times 32 is 1,440. And then what do I do to solve for y? Divide, I agree, by 36. Divide by 36. We get y equals 40. Awesome. That means this side would be 40. So they're proportional, and we're going to cross multiply today. That's it. And I know you guys cross multiplied last year, right? Okay. Let's try another one. Example number 2. No, not a lot. Just want to make sure we understand what we're doing before we keep going. Example number 2. Let's say I have, well, let's do that triangle again. And then let's put a line right here. It's supposed to be a straight line. It's close. Let's say I have triangle ABC, and I have triangle ADE. So they're proportional. They're congruent, right? If I tell you that this piece is 50, but this one is 200, I want to find this one if this is 20. So we have two triangles there. We're going to start with the big triangle over the little triangle. I always like to go the big over the little. You can go the other way too. It works both ways. Big over little. So if I start with my big triangle, I have on my side, I have x. What is the other side in the small triangle that matches x? $20, exactly. This side's here, 20 is here. Equals. My big triangle, the base is 200. What is the base of my little triangle? 50. And so now we're going to cross multiply. I always like to go the direction of where my variable is first. So x times 50 is 50x equals, then we multiply 20 times 200. 20, I'm going to write it out so you guys see where it comes from, times 200. So I have, whoops, come on, change for me. There we go. 50x equals 4,000. And now what do I do? Yes, divide by 50. Divide by 50. I get x equals 80. Very good. All right, so give me questions so far. Okay. All right, I want to talk about a scale on a map. We use a scale on the map to represent different lengths, right? A lot of times on a map you see that like 1 inch means 10 miles or something like that, or maybe it means 100 miles. You guys seen those on a map before? Okay. So on a map, that's what that means. That's your scale. So now if I have a map and I go on there and measure from Deckerville to Bay City, and it's 2.5 inches, right? I want to know how far that is. How do we figure it out? Okay, so we're going to start with our given information over x equals our scale. Okay, so here is example number 3. If I have a scale of 1 inch is 10 miles, how far is 2.5 inches? All right, so this is our given information. That goes on top. Put it up a little bit. Divided by x equals our scale, which is 1 inch per 10 miles. Charlie, Aubrey, please and thank you. Charlie, thank you. You can sit here and pretend like you're paying attention to me. That's fine, but all right. So now that I've got it into proportions, how do I solve for x? Cross multiply. X times 1 is 1x, and 10 times 2.5 is 25. Very good. All right. Let's try another one. How far is 3.8 inches? So again, we take our given information, 3.8, put it over x, equals our scale. And in this case, our scale is 1 inch per 10 miles. It's part of the same example. So if we cross multiply, x times 1 is x, and 10 times 3.8 is 38. This is exactly what you have to do for 14 and 16. Actually, 14, 16, actually a lot of them, but. Okay, so let's go to another example. Example number 4. Example 4. A model car is 1 to, 64? Sounds good. And the actual length of the car is, I don't know, how long is the car? 14 feet? Yeah. Sure, sounds good. 14 feet. I want to know how wide. All right. And actually, I don't want to know how wide. I want to know how long is the model. Is the model. Try that. Sorry about that. All right. So first of all, usually we do our given information over x, but in this case, I have the actual car length. So I'm going to go x over 14 equals our ratio, or our scale, as they said, which is 1 to 64. All right, so now we cross multiply. As I said, I like to go in the direction of x. So I have x times 64, or 64x, equals 1 times 14. Then what do I have to do? Divide by 64, exactly. We get x equals 0.219 if we round feet. Okay, so as long as we set our model up the same way, let's do one last one, and then I'm going to let you guys start your homework. Okay? Number 15, again, we're going to set it up, or number 15, example number 5. Find a scale for 175 miles is 2.5 inches. Yes, ma'am. Depending on the given information. So in that one, our scale was 1 to 64, right? So you're talking the model is 1, the 64 is like the actual. So when it gives us the actual car length, we have to put it on the bottom. If it gives us the model, we have to put it on the top. Does that make sense? Okay. So in this one, I need to make a scale. And remember, we always do inches to miles. So what do you think I'm going to do with these two numbers? What do you think we have to do? Okay, go ahead. Right. But what we got was we had the actual car length. We put it on the bottom. That's where the actual car is. We wanted the length of the model, so that's why we put the X on top. Okay? Model over actual. You can think of it that way. All right. In this case, we're going to divide these two. So we're going to take 175 and divide by 2.5. We get 70. That means for every inch, it's 70 miles. So we're going to say 1 inch. We're going to put a little colon in the middle. Represents 70 miles. All right. So same thing. You're going to have one in your homework that's very similar to this. Okay. If I said we had 200 miles, and we want a model that represents 1.5 inches, we would divide them. And we would say 1 inch is 133.3, repeating. I didn't do a very good example, did I? Miles. All right. So you're just dividing the two of them to make your model. Okay? Everything in this lesson is cross multiply. All right. So we are on page 134. 6 to 38 even. Number 6, you are doing exactly what we did at the very beginning of the notes. Okay? It says in number 6, the figure are similar, identify the corresponding sides and angles. So you just set your angles equal, and you do your sides, just like we did at the very, very beginning. Okay? All right.